Hey there, ladies and gentlemen. Welcome to our last notes of Unit 10. 10.3, we're going to talk about dilations and symmetries today. So just like we have the last few days, we're going to start off with talking about what it is. So a dilation is a transformation that produces an image that is the same shape as the original. It stretches or shrinks the original figures. Okay, so that makes this different than all the other ones we've talked about before because we are stretching and shrinking that. So then a dilation is not an isometry, which keeps the same shape and the same size. So these are not the same size, so that's why this is not an isometry. So dilations are also known as resizing. All right, so the description of a dilation includes a scale factor and the center of dilation. So you'll see it say D, and then we would say 0 and then 1/3. So 0 or O, sorry, that's an O, not a 0. This stands for origin. So this is your center. And then 1/3, this is your scale factor. So this is what we are timesing all of our points by. And that is going to tell us if it's going to shrink or if it's going to expand. So if the scale factor K is greater than 1, then it's an expansion. If the scale factor is between 0 and 1, so a decimal or a fraction that's between 0 and 1, it's called a contraction. So it gets smaller. So to dilate, we're going to multiply by the absolute value of the scale factor. Your scale factor should be positive anyways, but just in case, absolute value. All right, so let's go ahead and look here. It says find the image of ABC under the dilation of O2. So first, let's go ahead and graph our first points, our pre-image points. So we're at -1, 0, so that's A. Then we're at B is at 2, 2. And then C is over at 3, 2. Ooh, there we go. So it's kind of a skinny triangle there. Now what we're going to do, and the O is just because it's based off the origin. So we're just going to times everything by 2. So we get -2, 0. So we're going to go -2, 0. So that's my A prime. B is going to become 4, 4. So we're going to go over 4 and up 4. So that's now our B prime. And C prime becomes 6, 4. So I just times everything by my scale factor. So over 6 and up 4. So C prime. Kind of nice that I have different colors. Yours is not going to probably show up as well because you don't have the same different colors, but that's okay. All right. So dilations are actually kind of nice because they're not too difficult. We just multiply by the scale factor. So if we look here, let's go ahead and graph our original one. It's at 2, 0 for A. B is at 2, 4. Oops, I put a prime there. And then C is out at 4, -4. So we're going to go down this time. I threw that prime again. Okay, so we're going to connect all that. And now we're going to go ahead and times by 1/2, or we're going to divide by 2. So we get -1, 0. So that's our A prime. B is going to become 1, 2. So over 1, up 2, B prime. And then C prime is going to be 2, -2. So 2, -2, C prime. So here we see that it is a smaller shape. So if your scale factor is less than 1, you should see it be a smaller shape. All right, so let's go ahead and look at this one. It says the triangle ABC has vertices as given. Find the image of triangle ABC after the dilation centered at the origin with a scale factor of 2. So what that means is we're going to take all of those points and we're going to times them by 2. So A prime is going to be now -2, 2. So let's go see. -2, 2 is here. -2, 2. and negative 2, 2. So automatically you can say it's not C. All right, B prime. We are going to take 2 and negative 2. We're going to times both by 2, so we get 4, negative 4. So we're going to go over 1, 2, 3, 4, and down 1, 2, 3, 4. Awesome. Here we're going to go 1, 2, 3, 4, down 1, 2, 3, 4. So this one is out. So it's either A or it's none of the above. So let's go ahead and do C prime. So we get negative 2, negative 4. So negative 2 and 1, 2, 3, 4. Awesome. So it is A. A is our answer here. Dilations, short and sweet. Let's also talk about symmetry. Symmetry, a figure has a symmetry if there's an isometry that maps a figure onto itself. So remember, isometry says that it's same shape and size. So if I can map onto itself, then it's going to be it. If the isometry is a reflection of a plane figure, isometry, we'll put that in, is the reflection of the same figure. The figure has a reflectional symmetry or line symmetry. So it's possible for the figure to have more than one line of symmetry. So you could have something that's reflected onto itself with a line of symmetry. So if we look at our first one here, we have one line of symmetry. My line might not be quite exactly right, but or you could have things that have multiple. So if we look at the triangle, I can fold it this way, or I can fold it this way, or I can fold it this way. So I have 3 lines of symmetry there. If we look at the cloud has nothing that I can like call it as a line of symmetry. So this has none. It's not symmetrical. If we look at our pentagon here, we can go that way. That's the only one. The like no sign we could do here, or we could go this way. Our lightning bolt, yep, that's a no. So there's none. And this star figure, not all stars are symmetric, but this one we have line symmetry here and here. And we have ones here. So we're up to 3, 4, and we can go 5 and 6. That one has a lot. We have 6 lines of symmetry. And then if we look at our little cross symbol, we can go this way or this way. Those are the nice easy ones. We also can go diagonally through this one. So we have 4 there. So not only is there line symmetry, sometimes there's rotational symmetry. So in rotational symmetry, we have the figure has rotational symmetry if its own image for some rotation of 180 degrees or less. Rotation. There we go. A figure that has a point symmetry has 180 degree rotational symmetry. The angle of rotation for symmetry for rotational symmetry, there's a lot of rotations in there, guys, is the smallest angle needed for it to rotate onto itself. So what that's saying is if we look at this square here, we can divide this into a chunk that rotates, so goes either clockwise or counterclockwise and repeats onto itself. So with that is we look and think about our line symmetry and we say about it to rotate. So if it has line symmetry, there is a chance, a good chance that it is going to have rotational symmetry, but that does not always happen. If we have rotational symmetry, N, which is our lines of symmetry. So how many lines of symmetry? So our angle of rotation is going to be 360 divided by the number of lines of symmetry. So if we go ahead and look at this square, I can split it in half this way. I can split it in half this way. We can also go diagonally. So this one does have rotational symmetry. I can take a chunk and I can rotate it. So there's 4 lines. So we're going to do 360 and divide by 4. So this has rotational symmetry of 100 or 90 degrees. And we also have rotational symmetry of 180 degrees. If we look at our next one, we did this before. We had 3 lines of symmetry. So we can take 360 and divide it by 3, and that is going to give us 120 degrees. All right, so a heart, this has 1 line of symmetry. This does not have rotational symmetry, though. I can't take that left half of the heart and rotate it to make it to the right half of that heart, okay? So this one has no rotational symmetry. Okay, so if we look here, again, we can split. We have 1 line, but I can't take that top half and rotate it to give me my bottom half. So no rotational symmetry. Okay, so let's go ahead and look at that no sign. If I split it here, I can rotate that 180 degrees, and that's going to give me the other shape. I could do that with this also. So if I go 360 and divide it by 2, that's where my 180 degrees gets in. All right, we got a hexagon here. We have through the corners, we could go that way. So that gives us 3 of them. Or we could fold it in half. So that gives us another one. We could fold it diagonally there or there. So we actually have 6. So we're going to take 360 and divide by 6. So that gives us a lot of points of rotation. So that gives us 60 degrees, but we also could go 120 degrees and 180 degrees. So we got lots of different types of rotation there. All right, our X we did before. I'm going to change colors because we're getting cramped. We're going to go that way. So we could have 180 degrees rotation. We can go this way, this way, this way. So we had 4. So we actually can do a 90-degree rotation. What that means is, and it kind of shows it better here than with that square, is I could take this corner here and I can rotate it 90 degrees, and now it gives me this shape over here. I can rotate it at 180 degrees, so that gives me this shape, and then I can rotate it again, and we see there. So I have that. That's why I have multiple angles here. So 360, we already divided by 4 before we get 90 and 180. And we're going to see the same thing. This cross here is just about like that X. We've got 4 lines, so we have 90 degrees and 180 degrees. All right, there you have it, ladies and gentlemen.